Hello everyone, welcome to Chapter 7 Haloalkanes SK025 Chemistry. In this video, we are going to talk about Chapter 7.1 Introductions to Haloalkane. So by the end of the lesson, you should be able to draw the structures and classify primary, secondary, and tertiary alkyl halides. Name the primary, secondary, and tertiary alkyl halides according to IUPAC nomenclature. Describe haloalkanes as compound that contain polar bond and a carbon that bearing the halogen is susceptible to nucleophilic attack. Before we begin, the class of compound haloalkane is also known as alkyl halides. Both refer to the same class of compound with the symbol Rx. R represent the alkyl groups, and then X represent any of your halogens, which is the element from group 17. So haloalkane is where your halogens atom X make up either you have fluorine, chlorine, bromine, or iodine bonded to an sp3 carbon atom. Recall back sp3 hybridized carbon, it refers to a carbon which having 4 single bond, okay, 4 sigma bond. Alright, so haloalkane or alkyl halide can be represented using this symbol, in which this one is your alkyl group and then X is your halogens. And then we are able to draw this delta negative on top of this halogen due to the halogen is more electronegative. And then the carbon that bearing this halogen group will be delta positive. Alright, we say this carbon is our electrophilic carbon. So next, let's look at the classifications of alkyl halide or haloalkanes, which depends on the type of carbon that is bonded to the halogen's atom. So it's quite straightforward. It depends on what is the carbon that we attach to. So looking at this table, if you say it is a methyl halide, so that means the carbon that bearing your halogen group is a methyl carbon. So if we want to classify into primary, secondary, or tertiary, so look at the examples given here. The chlorine atom attached to the carbon, which is a primary carbon. Therefore, this haloalkane is a primary haloalkane. Similarly, the halogens attached to the center carbon here, which is a secondary carbon, as they have 2 carbon neighbor. Therefore, the haloalkane here is a secondary haloalkane. And the next example, tertiary haloalkane. Looking at this Cl bonded to the carbon, which is a tertiary carbon, as it has 3 alkyl neighbor. Okay, 3 carbon neighbor. Therefore, this haloalkane is a tertiary haloalkane. So it depends on the type of carbon these halogens attach to. Well, next, let's look at the IUPAC nomenclature. We want to name a haloalkane. So the rules for naming an alkyl halide or haloalkane follow exactly the same rules for naming an alkane, which means you figure out what is your parent, which is the longest carbon chain, and then you do your numbering. And then next one, number 3, you arrange the alphabetical order if you have more than 2 substituents. So the rules same as the one for alkenes. And we treat that halogen substituent same as alkyl groups, and we need to follow the alphabetical order. We have fluorine, which as a substituent we call it as a fluoro, and then chlorine as chloro, bromine as bromo, iodine as iodine. Alright, so let's look at the examples here. We have structures like this. First of all, find your parents. So we start from the right-hand side. Carbon number 1, carbon number 2, 3, 4, 5, and 6. So parents will be hexane. And at positions number 3, you have a methyl group and an iodyl group. So according to alphabetical order, we start from I first, then only followed by methyl groups. So the full name for these structures is 3-iodyl, 3-methyl hexane. So for this one, the halogens group attached to a tertiary carbon. So this is a tertiary haloalkane. So the next structures, we have a cyclic compound, so the parent name cyclohexane, and at the same positions, we name this one as carbon number 1. We have a methyl group and a fluorine atoms. So the names goes like this. We have 1-fluoro-1-methyl cyclohexane, or you can also name this as fluoromethyl cyclohexane, as both the substituents located at the same positions, and we always name the carbon with substituents as our carbon number 1. And for this one as well, we have a tertiary haloalkane as the fluorine is attached to a tertiary carbon. All right, so for the next structures over here, you can see, first of all, we need to find the parent. So the longest carbon change either from the left or from the right, you got 4 carbon. So we have butane as the parent. So now you have to look carefully about the positions. If I start from the left-hand side, I will have 2 substituents at carbon number 2 and 1 substituent at carbon number 3. If I start from the right-hand side, I will have 1 substituent at carbon 2 and then another 2 substituents at carbon number 3. So preferable with lower sets of number. So we start from the left-hand side, carbon 1, 2, 3, and 4 as our parents. So at carbon number 2, there is 2 methyl group, and positions number 3, there is a chlorine atom. So follow alphabetical order. We have 3 chloro, 2,2-dimethylbutane. Remember, 2 groups of methyl group, there is a prefixes di. So for this one, fluorine attached to a secondary carbon, therefore this is a secondary haloalkane. The next example is to draw the structures, follow the names given. So 4-fluoro-112-trimethyl-cyclohexane. So the parent is cyclohexane with 4 substituents. 4 number refers to 4 substituents. So this will be your structures. Okay, cyclohexane 112-trimethyl-4-fluoro. Fluorine attached to a secondary carbon, therefore this is a secondary haloalkane. The next structure is 4-bromo-4-chloro-2,2-dimethylhexane. So parent now is a straight change hydrocarbon hexane. Alright, so positions number 2, there's 2 methyl groups, and then positions 4, you have 1 bromo, 1 chloro. So both halogens attached to the same carbon, and this is a secondary haloalkane. The next example here, you have cis-1,3-dichlorocyclopentane. So this is a cis isomer. Recall back, cis trans-isomerism. First requirement is the restricted rotation. And the second requirement is at each carbon, you need to have 2 different groups. So you may want to draw out the structures first before you identify the cis isomer. And then you will get the structures at the end. Okay, cyclopentane at positions 1 and 3, there is 2 chlorine atom. Okay, cis isomer refers to the chloro at the same side or the hydrogen at the same side. Alright, so fluorine, both are attached to the same similar carbon, which is a secondary carbon. Therefore, this is a secondary haloalkane. So next, we want to look at another important features for this haloalkane or alkyl halides. It's a polar CX bond. So the CX bond in haloalkanes, this CX refers to if you have CF bond, CCl, CBr, or CI bond. So they are all polar bond due to your halogen X is more electronegative. And we can use the symbol delta negative on this halogen. And then this will result in the carbon atom to be electron deficient or delta positive. So halogen is electron rich and the carbon is electron deficient. So if we look at this diagram, we have an electrophilic carbon and we have a nucleophilic halogen. So delta positive carbon is where we are going to attack. And then here you got a more electronegative halogens. So this electrophilic carbon, your carbon center, is susceptible to nucleophilic attack. In other words, this electrophilic carbon will be attacked by a nucleophile. Okay, so imagine that we are going to attack this carbon and then kick out the halogens. So that will be explained in details in our chemical properties of haloalkane. So that's the end of our chapter 7.1. I'll see you again in the next video.